Okay, good morning dear students and welcome for the physics class. Today we are going to start with the fourth chapter in your first UC. So that is motion in a plane. Okay. So in this chapter we are going to learn about the vectors. Right? Okay. So in the previous class or previous section, previous chapter, we have learned about the motion in a one dimension. So in a one-dimensional motion, there are only two possible directions. One is a positive direction and another is negative direction. But when we come to the case of motion in a plane or a motion in a space, there we must have the knowledge of vectors. Why? Because the motion in a plane, if you want to express it in terms of the vectors, then we must have the knowledge of vector language. Okay, so about the vector language we are going to study in this chapter. So first, we study what we mean by the vector. Okay, so vectors means what? Vectors means these are the physical quantities which have both magnitude and direction, are called as vector quantities. Okay, here these physical quantities we are going to have the magnitude as well as the direction. These are called as the vector quantities. For example, we can take force. So force is a vector quantity, so which has both magnitude and direction. Okay, and other than force we have the acceleration. So already in previous chapter we have studied about the negative acceleration and the positive acceleration. That means acceleration is also vector quantity because it has both magnitude and direction. And next velocity. So in the previous chapter also we have studied about the negative and the positive velocity, right? So that is also a vector quantity because it has both magnitude and direction. Like the displacement, it is also a vector quantity because it has both magnitude and direction. So these are some examples for vector quantities. Okay, right. Alright, the physical quantities which have both magnitude and direction. Direction is specified direction. Magnitude and specified direction are called as vectors. For example, we can have velocity, acceleration, force, displacement, etc. etc. Okay? And next one is the scalar quantities. The scalar quantities. What do you mean by the scalar quantities? The physical quantities which have only magnitude but no direction. The physical quantity, they do not speak about the direction. Okay, those physical quantities are called as the scalar quantities because they don't have any specified direction. They have only the magnitude. For example, mass. Mass is a physical quantity having the magnitude, but it don't indicate any direction. In which direction the mass is acting? No, we can't say. Right? So mass is a scalar quantity. And also length. Length is a scalar quantity. And time is a scalar quantity. Okay? Volume. So volume also a scalar physical quantity. It's clear. Okay, and we can also say the temperature or energy. So these are all the scalar quantities. So let me write them. The physical quantities, the physical quantities which have only magnitude and no specified direction. No specified direction are called as scalars or scalar quantities. Okay. For example, we have mass, length, temperature, time, energy, etc. etc. These are the examples for scalar quantities. Okay. Next, we are going to have the representation of a vector. Representation of vector. How can we represent the vector? Okay. So a vector will be represented with the help of arrow marks on the letters. Okay. So physical quantities will be represented with some alphabets. Force will be represented with F. Okay. Acceleration will be represented with A. Velocity will be represented with small letter B. Right. So now, if you write an arrow mark above them, and that will be representation of a vector. How? For example, we have force and it is a vector quantity, right? So force is a vector quantity. To say this one, we write force and above here we are going to plot a arrow mark. And acceleration above which arrow mark. Velocity above which arrow mark. Right? So this is how we can represent the vectors, right? And here the starting point of this arrow mark is called as the tail of the vector, and this ending point of the arrow mark will be called as the head of the vector. So look here, right? So it is what? The tail of the vector, and it is head of the vector. Head of vector. Then just we want to represent the magnitude of that vector, then how we can represent that? Just look here, the magnitude of vector is given by, so here I consider the force vector, look here force, and just I want to tell about the magnitude. Just magnitude, then it will be given as modulus of vector F. So it indicates only magnitude. If you write like this, it is indicating only the magnitude. It won't say anything about the direction. So modulus of vector F, it is only the magnitude. And complete, if you write a F over what arrow mark, it includes both magnitude and direction. This say about the direction as well as magnitude, but this one will say about only the magnitude, no directions. Is it clear? Okay. So you just look here. If I write the vector here, so it includes both magnitude and direction divided by modulus of vector F. It has only the magnitude. It don't have any magnitude. Then so vector F is divided by magnitude of F. So here, this F and here, in this vector F, whatever magnitude we have, both will get cancelled. And whatever vector we are having here, this will indicate unit vector because it don't have any magnitude. Look here, vector F, the above quantity have both magnitude and direction, but the below quantity which have only magnitude. So from this, magnitudes will get cancelled. from numerator and denominator. And whatever we are given this, that will be called as the direction of a vector, and there the magnitude will be unity. Magnitude will be unity, so this is called as a unit vector. Is it clear? Okay. So next we are going to have some of the different types of vector. We'll discuss that in the next class. We'll take a screenshot and write it in your notes.